students. Today we'll complete part 14, that is Biomolecules, part 1, class 12 science chemistry. As the name suggests, here we are going to discuss about the biomolecules. Now, what is the biomolecule? Biomolecules are nothing but the biological molecules. That means these are the chemical compound that is being produced from the living organism, from the cell. Okay, living organism is either from plant or from the animal. Now, biomolecules have a wide range because of their size, structure, and variety of function. What is the importance of biomolecule, or why to study the biomolecule? The answer is, or the reason is, for our growth from childhood, when we start growing up, or any animal that start growing up, the structural unit that is being deposited in the body comes from the biomolecules. For example, this carbohydrate, protein, food that we are consuming in the form of food. These fruits, this oil, fats, different fish, egg, whatever you are taking, therefrom it get deposited and make the structural unit of the body. Then, sometime when we fall sick, we take the medicine, okay, and it make the functioning of the body proper in the proper way. There also the biomolecule works. Next, one important phenomenon, perhaps all of you have observed, when you see a kid, okay, the kid inherit the different characteristics from their parents, from both the parents. Now, how the heredity comes, or how he or she inherit the character from their parents. This inheritance also come in the form of a biomolecule, that is a nucleic acid, DNA or RNA. So these are the things where biomolecules play a role. So if we study the biomolecules in detail, then we can solve different mystery of life. So biomolecule is a non-living thing, it's a non-living chemical component, but it is the most essential thing for the living being. Without biomolecules, we are nothing. So something non-living is performing all the living activities. That's why it is very much important. Now, we can classify the biomolecule as carbohydrate, protein or amino acid, then enzyme, vitamin and nucleic acid. Under carbohydrate in your course, these carbohydrates are mentioned. So we have to know about the glucose, fructose, lactose, starch, cellulose and glycogen. Then under nucleic acid, we have to cover this DNA and RNA part. So these are your biomolecules, which are very much vital. Now, what is the carbohydrate? The definition of carbohydrate is it's a polyhydroxyaldehyde or ketone or substance which gives this substance on hydrolysis and contain at least one chiral atom. Here chiral atom is, it is a chiral carbon atom. So already you know what is a chiral carbon atom. Carbon have 4 valency. If 4 valencies are filled with different groups or atom around it, then the carbon is termed as chiral atom. So carbohydrates are aldehyde or ketone with a number of OH group. Polyhydroxy means it will have a good number of 3-4 hydroxyl group in it, and it must have a chiral carbon in the structure. Carbohydrates are also known as saccharide. Okay, saccharide is a Latin term. Saccharide means sugar. Saccharide or sugar, it means sugar. Now see, the general formula of carbohydrates are CxH2O. One Y must be there, okay? A number of water molecules there. That means water is what? Water is hydrate. So this formula is saying it's a hydrate of carbon, and hence this is called carbohydrate. Now let's see the classification of carbohydrate. So carbohydrate, depending on the chemical properties and structure, can be categorized as monosaccharide, disaccharide, oligosaccharide and polysaccharide. Now what are the monosaccharide? Carbohydrate or saccharide that do not hydrolyze. Okay, that means they will not react with water to form any other simple carbohydrate. These are called monosaccharides. So for monosaccharide, hydrolysis will not result in a new or it will not break down to form a new simple carbohydrate. Under monosaccharide, we have to discuss here about glucose, fructose and galactose. These are the example of monosaccharide. Next is your disaccharide. Di means 2. So this carbohydrate on hydrolysis produce 2 sugar molecule or 2 carbohydrate, 2 simple carbohydrate it will produce on hydrolysis. Example sucrose, lactose and maltose. Then oligosaccharide are the carbohydrate that on hydrolysis produce 2 to 10 sugar molecule. That means if a saccharide is producing 3 simple carbohydrate, okay, then also it will come under the category of oligosaccharide. This disaccharide is also a oligosaccharide. So oligosaccharide are the carbohydrate or saccharide that on hydrolysis produce 2 to 10 molecule of simple carbohydrate. Example is raffinose and styrose. Then we get polysaccharide. Polysaccharide on hydrolysis produce 10 or more than 10 sugar molecule. That means on hydrolysis you will get 10 or many more than 10 simple carbohydrate. Example starch, glycogen and cellulose. Okay, so these are the classification of carbohydrate based on how many simple molecule of carbohydrate it is producing on hydrolysis. Now we'll see the monosaccharide glucose. The formula of glucose is C6H12O6. Here flowchart is given with different reaction of glucose. So let's see. When glucose is treated with hydrogen iodide, it is heated with hydrogen iodide, it produces N-hexane, normal hexane. That means an open chain of alkene it produces. On oxidation with dilute nitric acid, it produces glucuric acid. If you are doing the oxidation in bromine water, then you get gluconic acid. With hydrogen cyanide, it produces cyanohydrin. If it is treated with excess of acid anhydride and pyridine, it produces a pentaacetate. On reaction with sodium borohydride, it is a very strong reducing agent. It produces sorbitol, which on reaction with acetate anhydride and pyridine produce a hexaacetate. Okay, so these are some reaction of glucose given. Now, what is the importance of this reaction? The reactions are very important because here from this set of reaction we can derive the structure of glucose. Otherwise you see glucose is a big molecule, 6 carbon with 12 hydrogen with 6 oxygen. The scientists, the researchers were confused that what will be the structure of glucose. So these reactions give them the clue about the structure of glucose. So from this reaction it is being derived that the structure of glucose can be presented as an open chain structure. Now who had given this open chain structure of glucose? Fischer's model. From Fischer's model we will get the open chain structure of glucose. Now we get 2 isomers of glucose, one is D-glucose, another is L-glucose. Now in this D-glucose we get 6 carbon atom in the chain. Here you see the functional group is aldehyde group, C double bond OH, and you are getting so many hydroxyl groups. So it is what? It is polyhydroxyaldose because aldehyde is the functional group present in the structure. Now from the end side, Fischer model or Fischer projection formula for any compound is always a 2-dimensional representation. Okay, that means on a plane, on a paper you can give the whole structure. It is not 3-dimensional, it just gives the 2-dimensional idea. So how to get this D and L form? See, from the bottom if you start, the first carbon is achiral. Why it is achiral? Because here you are getting the carbon where two hydrogen and one hydroxyl groups are attached. Two hydrogen means common atom, so it is not chiral, it is achiral. Next carbon you see, this carbon, one side this big group is there, second valency with OH group, third valency with hydrogen, and fourth valency with CH2OH, which is different. This side and this side are different. Okay, that means this carbon here, four valencies are linked with different groups or atom. So this is the first chiral atom from the bottom. Now the first chiral atom from the bottom, okay, here when hydroxyl group is on the right hand side, that isomer is called D isomer, okay, and if the hydroxyl group is present on the left hand side, then that isomer is termed as L isomer. So in open chain structure of glucose we get two isomer, D glucose and L glucose. So these two optical isomer differ in configuration around any other carbon atom other than the C1 carbon atom. In D glucose, OH group on the first chiral carbon from the bottom is on right hand side, okay. OH group is on the right hand side, hence it is D glucose. If it is on the left hand side, it is L glucose. Next will come for the cyclic structure of glucose. Now in the cyclic structure formation of glucose, what happen, you see, this is your glucose structure. In this glucose structure, the fifth carbon, okay, the fifth chiral carbon have OH group. Now a arrangement will happen here. In the arrangement, what happen, the hydrogen from here will shift to the oxygen of the first carbon. So what will be the change? The change will be the double bond will break and it will form a OH group. Okay, OH group form here. Hydrogen is already present. Now here one valency will be created on carbon because the double bond broke into one, and here also this OH bond broke because hydrogen left the molecule, so on oxygen also one valency created. So this oxygen and this carbon will get joined. That means carbon 1 and carbon 5 will join via a bridge. And what is the bridging atom? The bridging atom is oxygen. This bridge form above the plane. It is not forming on the plane. Here you are seeing it on the plane, but actually it is above the plane. Okay. So your structure become like the first carbon, earlier it was an aldehyde group, but now it is having one hydrogen on one side, one OH group on one side, and it is connected to carbon 5 with an oxygen. So carbon 1 and carbon 5 joined with the oxygen, OH and H group is there, rest of the things are same. Okay, so you are getting a ring structure now. That means carbon 1 and carbon 5 are joined with the oxygen. That means you are getting a ring of 6 atom, but this ring is not homocyclic, it is heterocyclic because one molecule, one hetero oxygen molecule atom is here. So we can compare this structure as this pyrene structure, and here's this glucose. The cyclic structure of glucose is called glucopyranose. We have started with D glucose. You see OH group is on the left hand side, so it is a D glucose. So this isomer is called D glucopyranose. Now if you put a mirror, okay, if you put a mirror in this structure, then the enantiomer you will get will be like this. This bridging will not matter because it's above the plane, so it will not change if you are placing a mirror. So what will be the change? The OH and H group will be exchanged. Okay, lateral inversion happen in case of mirror, so you'll get that lateral inversion, and that is be known as alpha D glucopyranose. So this is the cyclic structure of your glucose. Next, formation of cyclic structure of glucose. Glucose is what? This is your aldohexose. Why hexose? Because 6 carbon is there, that's why it is called hexose group. So we are getting this alpha D glucopyranose and beta D glucopyranose. These two structures are same, just the presentation. These are same like this, but only the presentation is given nicely, like a benzene structure, heterocyclic molecule is presented. Next, formation of glucose. Where from we can get the glucose? See, we can take disaccharide. Okay, disaccharides on hydrolysis produce two molecules. Okay, two simple carbohydrate molecules. So if you start with sucrose, the formula is C12H22O11. On acid hydrolysis will add up water in presence of acid, in presence of an enzyme. It form glucose and fructose. See the reaction, what is happening here? We have chosen C12H22O11. Here we are adding H2O. So the formula will become C12H24O12 after adding water. Now once you get that C12H24O12, you break it into half. So what you'll be getting? You'll be getting 2C6H12O6, this two. Okay, so do remember one thing, all the formulas, the reactions happen in same way. You'll be taking this C12H22O11, you'll be adding water, the same thing you'll get. But only thing you have to remember is that when you start with sucrose on acid hydrolysis, in presence of enzyme invertase, it produces one glucose unit, one fructose unit. With same formula, if you have chosen maltose, in presence of maltase enzyme, it will produce two glucose unit. And if you have started from lactose, though the formula is same, in presence of lactase enzyme, it will produce one glucose unit and one galactose unit. So this part is very important. Question directly come as, what will be the product of lactose on hydrolysis, or write down the product when maltose is hydrolyzed with maltase enzyme. Or you might be asked, what is the enzyme used in the hydrolysis of sucrose? Okay, so this reactions you have to remember. The reactions are very easy, just you have to remember sucrose on hydrolysis, it produces glucose fructose, maltose produce 2 glucose, and lactose produce 1 glucose and 1 galactose. Next, depending on the chemical functioning of the glucose, we can divide it into two categories. One is reducing sugar, another is known as non-reducing sugar. Sugars are nothing but the carbohydrate. Glucose, fructose, these are sweet in taste and hence these are called sugars. Now what is reducing sugar? As the name suggests, they will be reducing in nature. They are reducing agent. Now why they act as reducing agent? Because of the presence of free aldehyde group or ketone group. Okay, so reducing sugars are good reducing agent. Their reducing property comes from the free aldehydic and ketonic group present in them. Now what is non-reducing sugar? These are the carbohydrates that cannot act as reducing agent because here they lack the free aldehydic or ketonic group. They are good reducing agent, non-reducing agent. Non-reducing sugars are, they have free aldehyde ketonic group, they don't have this. They give positive reaction towards Fehling test. In Fehling test, it's a reduction test. Sugar here act as a reducing agent. So they give positive test, Fehling test, and non-reducing sugar give negative Fehling test and Tollens test. Okay. Examples: the monosaccharide and some disaccharides are reducing sugars, and non-reducing sugars are higher. Okay, that means some disaccharide and most of the polysaccharides are non-reducing sugars. Next we'll see what is the starch. Now starch serves as a storage polysaccharide in plant. We get the starch in plant. It consists two component of alpha glucose. So starch on hydrolysis produce a large number of glucose molecules. That means you can say it is a polymer of glucose. Okay. Now you see this is a glucose unit. This is one glucose unit. This is another. This is another. Now here the glucose units are joined with this bond. Okay, what is there in the bond? You can see one oxygen atom in the bond. Now in starch, the bond that is in between the glucose molecule is called glycosidic bond. Okay, so these are called the glycosidic bond. In starch, what type of bond you get? You get the glycosidic bond through which the glucose molecules are joined. So one mark question if you are asked that what type of bond you are getting in carbohydrate, so your answer must be glycosidic bond. So this is your starch. Starch is a polymer of glucose molecule. And what they said, there are two components of glucose. Now let's see what these two components are. So the two components present in starch are amylose and amylopectin. Okay. Now what is that amylose and amylopectin? Before starting it, just think about a rice grain. Okay, you take a rice grain, and if you observe, you put a drop of water on it, you'll observe that some part of the rice get wet with the water, but some oily parts are there on the surface that is not get wet with the water. Okay, now from your observation you can differentiate into two parts: a smaller part that is not getting wet with the water, and the major part get wet with the water. So the one that get wet with the water is your amylopectin. Its majority, it is 80%, and the insoluble part is amylose, that is 20%. Okay, lesser, that do not get wet. So see here now, amylose is a straight chain polymer of D-glucose unit, right? And amylopectin is a branch chain polymer of the same D-glucose unit. So amylose is simple, straight, and amylopectin is a complex branch chain. Amylose contained in starch is 20%, amylopectin is 80%. Here straight chain structure, here branch chain structure. It has 1,4 glycosidic linkage, that means carbon 1 and carbon 4 are joined here with glycosidic bond. And in amylopectin you get 1,4 glycosidic bond and 1,6 glycosidic bond. That means in one side you'll be getting, it's a branch structure, so in some part you'll get the glycosidic bond between carbon 1 and carbon 4, and in other you'll be getting the bond between carbon 1 and carbon 6. Amylose are less soluble in water, amylopectin more soluble in water. It gives dark blue black coloration on addition of iodine, and amylopectin gives reddish brown color with iodine. Now next point, hydrolysis. On hydrolysis, it with amylase and alpha and beta amylase enzyme, it hydrolyzes completely, but it cannot be hydrolyzed with amylase enzyme. It does not form a gel when hot water is added, but this amylopectin form the gel when hot water is added. So when you boil the rice in hot water, you get a sticky gel kind, right? That is due to this amylopectin. Here is a mind map. Okay, so to remember this thing, we take the carbohydrate from the diet, the bread, the rice we are taking, this all the sugar, this all are carbohydrate rich food, all of you know this. Now this carbohydrate from food comes in the form of sugar, starch and cellulose. Cellulose is present in the plant, we cannot digest it, it is undigested. Okay, but we can digest sugar and starch easily. On digestion it convert into glucose. The glucose on oxidation store as energy. Okay, ATP, in the form of ATP, energy cell, it gets stored in the body. Whenever you need it, converted to ATP, and you can experience the energy. Next, the glucose, the excess glucose, okay, that are not converted to energy, they are stored in the form of glycogen, fats and non-essential amino acid. Now where the glycogen stored in the body? In the liver. Fat stored in the body, under the skin, the fats get deposited, and non-essential amino acid helps in the protein synthesis, that the protein we are consuming to synthesis this non-essential amino acid help us. So that all about our carbohydrate. I'll provide the PDF for this. You please kindly note down the content in your chemistry copy. Okay, that's all for today. Thank you.